When first looking at this series of systems of equations, it may look like elimination is impossible here because we do not have any coefficients that are the same. The top equation has coefficients of 5 and 6, and the bottom has coefficients of 2 and 3, and we need coefficients that are the same in order to use the elimination method, but not all hope is lost. If you'll recall, the multiplication property of equality says we can multiply an equation by whatever we want, provided that we multiply everything on both sides of the equation by that amount. So when I look at this second equation here, what I notice is that if I were to multiply everything in this equation by -2, or just 2 if you like, let's multiply by 2 because that's a little easier. If I multiplied everything in that equation by 2, what would it look like? Well, let's see. Instead of 2x, I would have 4x. Instead of 3y, I would have 6y. And instead of -5, I would have -10. And now I do have two coefficients that are the same, because that first equation was 5x plus 6y equals -8. Now the y's have the same coefficient, which means if I subtract these two equations, I can find the value of x. The y's will cancel and I'll be left with x. So let's do that. 5x minus 4x is 1x. 6y minus 6y is 0. And then be careful here with the negatives. This is -8 minus -10, which of course is the same thing as -8 plus 10. So that's just going to be a +2. And there we go. We've got the value of x. X is 2. So now we need to figure out y, and we can plug y into any of three equations. We could plug y into the first equation, the second equation, or we could plug it into this equation right here that we have multiplied by 2. Now, plugging it into the equation where you've multiplied is rarely the best way to go. Sometimes it is. We'll look at that a little later. Sometimes it is the best way to go, but in this case, certainly not, because multiplying by 2, all we did was make the numbers bigger. We don't want to deal with bigger numbers if we don't have to. I think the second equation is probably the easiest, just because no matter what, we're going to have to deal with negatives. Every one of these equations has a negative number in it, but that second equation, 2x plus 3y equals -5, has the smallest coefficients and the smallest constant. So if we're going to have to use negatives no matter what, let's at least use the one with the smallest negative. So let's substitute +2, excuse me, +2 in place of the x. And let's go ahead and solve. We'll simplify first. 2 times 2 is 4. And so we've got 4 plus 3y equals -5. And now we'll use the subtraction property of equality. That gives us 3y equals -9. And then now just the division property of equality gives us the solution. So we get y equals -3. So our x value was 2, our y value was -3, which means the solution to this system is 2, -3. Just like that. And that's how we can solve a system using elimination, even if maybe at first it doesn't look like we can use elimination. Sometimes there's a little trick we can do to set it up where elimination is still possible, and in this case, the fastest way to get the answer.